I suppose it's possible that one or two people may be wondering how I've come to any conclusions about how the sizes, dimensions of which to make this tram. I mean, I don't have any reference sources with any detailed dimensions, but I've got a couple of books. Manchester, Bury, Rochdale and Oldham Steam Tramway by a chap called W.G.S. Hyde, and Vertical Boiler Locomotives by a fella called Roland S. Abbott. And in those books there are one or two section drawings of trams, albeit without any dimensions. The Manchester, Bury and Rochdale book, in fact, does give a bit of detail on a very large steam tram that was sent to Australia, I think. And that machine apparently weighed about 13 tonnes, was 13 foot long, 5 foot 10 3/4 wide, with a boiler of about 4 foot 5 3/4 inches high. Now that's a bigger machine than the one I'm intending to represent. This tram will be smaller than that one that was sent to Australia, and is intended to be more indicative and representative of the sort of vehicle that ran around in the 1900 or so for a few years in England, in the UK. So I've made a fairly, well, I made an executive decision, fairly arbitrary, that the prototype dimensions of this tram, if it ever existed, and maybe it didn't, will be about 10 feet long and 4 foot 8 wide. And in outline, I'm using this picture in Roland Abbott's book to kind of represent where I'm going. I haven't followed this exactly, because looking at this picture, I think the wheelbase on that prototype tram is longer than the wheelbase I'm actually going to use on the model. But just trust me, at this stage I want to leave myself a bit more flexibility, because I haven't made any drawings. I want to leave myself a bit more flexibility as to where the boiler and the motive power unit goes. And certainly the engine is likely to be outside the wheelbase, so I've kept the wheelbase slightly shorter. The wheelbase on this model will be 80mm. You do have to get used to working in metric and imperial when you fiddle about with projects like this. Just trust me, it's easier to use both sets of measurements really for some things. I've roughed out a couple of bits of 16th thick steel to make the frames of this tram. I've also roughed out and I had to machine that because I never had anything in the right size. From a bit of flat bar, I've started to rough out what will be the connecting rods. I'm a great believer in clamping everything together and drilling one part from another. That way you don't have to measure too much, and hopefully it'll all fit. So I've got a couple of pre-drilled holes here, which will be the centres of the axles. So what I've got to do is to clamp the connecting rod blanks to one end and then drill through the other end, and then hopefully both the connecting rod centres and the centres of the axles on the frames will all be the same. That is the plan anyway. What I've decided is that the overall frame length is going to be 190mm. The centre between the axles will be 80mm. This thing is going to have to be 45mm gauge from the Garden Railway, I think, because of the inside frames. I'd much rather they were outside frames, but they're inside because the photographs I've seen seem to indicate that these little Bayer Peacock Wilkinson designed trams in fact had inside frames, which makes it virtually impossible to have a 32mm gauge. And I've worked out, which will be the next step, that the spacers I'll have to machine to separate the two frames will have to be 1.4 inches wide to allow sufficient room each side to fit the wheels at 45mm centre. So I think the next job is to machine the spacers, machine the wheels, machine some axles, shove it all together approximately, and see if my supposed plan works out, which it may or it may not. The first task is to make some wheels. Unfortunately, I'm only going to get 3 wheels out of this off-cut knob end of steel, so I'll have to find another bit to make the 4th wheel. The plan is that the diameter over the outside of the flange of each wheel will be about 42mm, that's 1.65 inches, and the diameter over the tread will be 38mm, which is about 1.5 inches. The OD of that flange is now turned to about 1.525, so in theory if I just touch the end of the carriage and then use the top slide and run that over at 3 degrees, sort of hoping we'll end up somewhere where we're supposed to be. I used a small V tool just to create a small profile in the side of the wheel that faces out. Just did that by eye, no measurements really. And the next step is to just run a 5/32 drill through the centre there, which will be the unless it needs truing up, that's going to be the diameter of the stub axle, but we shall see. The wheels will be Loctited onto the axles, so doesn't need to be a dead fit. To leave some room for the Loctite, as you do. The drill doesn't seem to be wandering, so in my view that's good enough. This is what one would term a very unstable setup, so slow and steady does it. Notice I've drilled the trigger on my feed drill, drilled it and put a pin in. It just helps me control the pressure on the trigger so that I don't overspeed the feed. Well, you can't pull the trigger in too far. Right, not fantastic, but a little bit of work with a file and we'll have 2 coupling rods for the tram. The silly thing about all this is that being a tram, and when the side skirts are on, neither the wheels nor the coupling rods nor any of the motion actually will be capable of being seen. But anyway, I suppose one ought to make half an effort. So, for no good reason other than I thought I would, I'm mounting each wheel on an arbor, then placing the crank upon it, which is a good tight fit, and then the idea is to join tap the wheel through the crank 5BA for the coupling rod. No particular reason. I have actually cross drilled these cranks. You probably can't see it. There is a cross drill hole in there. Whether I actually use that, I really don't know. So I'm just going to drill through the crank an 1/8, which is the diameter of the crank pin, just to spot where I'm going to start the 5BA tapping hole. Extremely awkward to do this while I'm holding the camera, but it will find its own way. So we're just making a little pilot to start the tapping drill, and that will do that. I now just drill through the hole that I spotted, 5BA tapping size. Just pick itself up really. That's your 5BA tapping hole for the crank pin. And now, using my homemade tapping device, we just tap through the wheel 5BA for where the crank pin's going to go, and of course this will be in line with that hole in the crank from which we spotted it, so everything should be lined up. My homemade tapping device works exceptionally well, even if I do say so myself. Apologies for the noise of my compressor. I've temporarily fitted the motor. It's not permanent, but it's a start. And we have some sort of light. can't come out on the camera. I just guessed the gear ratio. I haven't worked out exactly what it is. Looking at the wheels going round, it can't be far off, I hope. I don't like to run the thing too long on air because the cylinders get very, very cold. I'm never quite sure if that's a good thing or a bad thing. Probably a bad thing. There's no oil going into it at the moment either. It's just got it connected up to the air hose. We'll call that limited success, I think. It obviously runs on the rolling road because we've seen the wheels go round. But I suppose one question would be, what would actually happen if we put some air on it on the bench? Will it go? Oh, it will. I'll be a bit careful because we've only got a foot or two to go here. Oh well, that's satisfying, isn't it? The wheels aren't properly fixed yet. I don't want it to go careening off. I like that. Working under pressure. Always a good sign. Excellent.